Introduction to comets. Comets are fascinating celestial objects that display spectacular tails as they approach the Sun. These icy bodies, composed of dust, rock, and frozen gases, become particularly striking when they develop tails that can be observed from Earth. Understanding what causes a comet's tail to glow involves exploring the interaction between the comet and solar radiation. Structure of a comet. A comet consists of a nucleus, a coma, and one or more tails. The nucleus is a solid core made up of ice, dust, and volatile compounds. As a comet approaches the Sun, the heat causes the ices within the nucleus to sublimate, or turn directly from a solid into a gas, creating a glowing cloud of gas and dust known as the coma. The tail forms as the comet continues its journey closer to the Sun. Solar radiation and sublimation. The primary cause of a comet's tail glowing is the effect of solar radiation. As a comet nears the Sun, the intense heat causes the volatile materials in its nucleus to vaporize. This sublimation process releases gas and dust particles into space, forming the coma and pushing material away from the comet's nucleus. Formation of the tail. The glowing tail of a comet is formed by the interaction of the comet's gas and dust with solar wind and radiation. The solar wind, a stream of charged particles emitted by the Sun, exerts pressure on the gas and dust released from the comet. This pressure pushes the material away from the Sun, forming the tail. Additionally, ultraviolet (UV) light from the Sun ionizes the gases in the coma, causing them to emit light. Types of comet tails. Comets typically have two types of tails, the dust tail and the ion tail. The dust tail is composed of small particles that are pushed away from the comet by the pressure of solar radiation. It often appears yellowish or white due to the scattering of sunlight. The ion tail, also known as the plasma tail, is made up of ionized gases that glow due to the interaction with the solar wind. This tail often appears blue and points directly away from the Sun. Tail alignment and appearance. The direction of a comet's tail is influenced by the position of the Sun relative to the comet. The ion tail always points directly away from the Sun, regardless of the comet's direction of travel. In contrast, the dust tail follows the comet's orbital path and is curved. The differing appearances of the tails are due to the different forces acting on the dust and ionized gases. The role of the comet's orbit. The shape and visibility of a comet's tail can vary depending on its orbit and distance from the Sun. Comets with highly elliptical orbits often develop more prominent tails when they are closest to the Sun, perihelion. As they move away from the Sun, the tails gradually diminish and may disappear entirely when the comet is far from the Sun. Impact of solar activity. Solar activity, such as solar flares and coronal mass ejections, can also influence the appearance of a comet's tail. Increased solar activity can enhance the interaction between the solar wind and the comet's gas and dust, leading to more intense and vivid tail displays. Conversely, lower solar activity may result in less pronounced tails. Observation and study. Comet tails are studied by astronomers to gain insights into the composition of comets and the dynamics of their interaction with the solar environment. Observations from telescopes and spacecraft help scientists understand the processes involved in tail formation and the effects of solar radiation on comets. Conclusion. A comet's tail glows primarily due to the interaction between the comet's gas and dust with solar radiation and solar wind. The sublimation of ices in the comet's nucleus creates a coma and tail, with the solar wind and UV light playing key roles in shaping and illuminating the tail. Understanding these processes not only provides insights into the behavior of comets but also enhances our knowledge of the solar system and the effects of solar activity on celestial bodies.